Hello everyone, this is Bryant. My team name is gachigachi.tv, kind of like YouTube, other things, but with the TV. Gachi is Korean, meaning that let's do it together, kind of like a slang. So gachi means let's do it together twice. I am the only member in my team for this hackathon. In this app, I'm going to present universal live casting platform. So let's see what it is. It's going to be exciting. Here's a problem. Imagine this. You are an influencer with millions of followers in YouTube. When you stream, you can easily get 100,000 views per video. But your friend told some of your content can be good for Twitch, and another friend told you YouTube is old, but Facebook video is the next thing. But streaming each one looks like to be a huge waste of time. You wonder, why can't there be a single platform where I can stream all at once? So here's our solution. Introducing Gachi TV. This is a unified single platform where you can visit and you can see all the live chat feed from different channels and interact with the user from different channels. You can also start streaming from this single platform, one platform, and it can broadcast to all different channels, whereas YouTube, Facebook, Vimeo, Twitch, etc. etc. Pretty cool, right? Let's take a look at our architecture diagram to understand the further detail how does this work. From a software architecture perspective, the end-to-end process starts from a streamer side that ended at the audience viewer side, who can be viewers from YouTube, Facebook, Twitch, etc. Let's dig down into further detail. When a streamer visits the website, he or she will be presented with a nice user interface with two different functionalities. One of the functionalities is a live chat, where it will pull the chat feed from the different streaming channels, then display the web page. Streamer can also interact with the audience by typing in the chat window. In addition, streamer can also click Start Broadcasting button to broadcast to all live streaming channels. To make this flow possible, we have a different microservices consist of an Azure App Service, Azure Media Service, and the Function as a Service based on the REST API, which will then communicate back to the streaming APIs to authenticate and to make transactions. Our main application is hosted on Azure App Service, which is built mainly with Node.js and Express.js. Two key tech stacks that enable streaming is Socket.io and App.pmeg. Socket.io gathers the input from the camera, then send the output to Azure Media Service, while send the keyboard input to our Function as a Service. Once the data from the camera is read, this will get encoded through FFPMEG first, then send the processed data to RDPMS in Azure Media Service. This will then forward that output toward the endpoint defined in Azure Media Service. This video data will hit our Function as a Service to authenticate with different streaming API service, then use different live streaming APIs to send the data to the audience. As for the chat, since we need to coordinate different messages from various channels, we need a messaging queue like Redis to synchronize chat messages. This was a high-level overview how this process works. Let's take a look at our technologies and see what we implemented and what we have not. So there are a lot of technologies that I plan ahead, and some are implemented and some are not, mainly because of time reason. On the implement side, we have Azure App Service, which is client-side hosting, and Azure Media Service, which is for RTPMS backend, and Node.js for client-side server, Socket.io, which is a messaging protocol for video chat and accessing our camera, etc. Twitch API is for chat and video API, only for partial use and tested. Express.js, which is a framework for REST, and it was used. And other things are HTML, CSS, JavaScript, which is mainly for programming. On the plan stacks, I was planning to use FPMEG for encoding decoding video, but it was only tested, never implemented. Redis or messaging queue for chat synchronization, but it was only planned. React.js, because once I got the Twitch API, I was trying to display, but didn't have time to implement that yet. YouTube live streaming API, I tested out, but there was an issue with the 24-hour authentication, and so I was a little struggle to actually get it resolved. Facebook GraphQL API, it was only planned. Vimeo live streaming API was only planned. Authentication for GCP, etc. Got it to work for some of them, but it was only tested out. So here's a demo. So from here, when you evaluate the website that is hosting Azure App Service, and then it would start right away for broadcasting, and I can toggle. And I can also type in the live chat, which will be then if I open another browser, just using the socket.io to actually see it, and so other person can also see it at the same time. So also one thing that was not completely implemented is our Azure Media Service, which is tested with the OVS, but not with our application. We are also able to implement the Twitch API. As you can see, I was authenticated and able to get the REST backend, but never implemented. So where to go next? So as you can see, we plan a lot of things, but then I was never able to implement that, most of them. But so focus on finishing at least one happy path, which is going to be Twitch API endpoint at this point. But then after that, we can expand the pattern for other live streaming API easily. YouTube, Facebook, GraphQL API, Vimeo. Each one will have a different API and how we authenticate it, but it will follow the same pattern. Then we want to make a more automated mechanism to authenticate and authorize, because some of things are a little hard-coded. And then want to create a listener agent to actively listen to the event and then execute REST call. And you want to further test improve the quality of live streamings.